This video will learn about hypergeometric distribution. The hypergeometric distribution is a probability distribution that is very similar to the binomial distribution. However, the probability that an trial hypergeometry experiment in exactly X successes when the population consists of n items, k of which are classified as successes. So here is the formula where kcx multiplied with n minus kcn minus x divided by ncn. The capital N is the population and the small letter n refer to the sample size. Alright, therefore, the probability of x is equal to x kcx n minus kcn minus x divided by ncn. K is the successes and minus K is the failures. A hypergeometry in a statistical experiment has the following properties. A sample size N is randomly selected without replacement from a population of N items. In the population, K items can be classified as successes and N minus K is classified as failures. The mean of the hypergeometric distribution is Nk divided by capital N, and the variance is small letter k and k multiplied with the population minus k multiplied with the population minus sample size divided by population squared multiplied with population minus 1. So let's look into the example. Cellcom company randomly selects 3 new employees from a total of 10 applicants, 6 men and 4 women. So here we have the classification. Let X be the number of women who are hired. The first one is calculate the mean and standard deviation of X, and B is calculate the probability that no woman will hire. Let X is the number of women hired, just as stated in the question. So, we want to calculate the mean. The formula to calculate the mean of hypergeometry is the number of sample size multiplied with the classification divided by the number of observation. So, we know that the total number of observation is 10. Here, we have 10 applicants and the sample size is 3 because here is the 3 new employees is selected. Therefore, the sample size select is 3. And K is 4. K classification refer to the question here woman. So woman, the company select only 4 women. Therefore, the K is equal to 4. So substitute into the formula to find the mean. 3 times 4 divided by 10 is equal to 1.2. Then next is find the standard deviation. Standard deviation is the square root of variance. So the sample size is 3 multiplied with K is 4 and the population is 10 minus 4, 10 minus 3 divided by 10 squared, 10 minus 1. The variance is 0.56. Then the standard deviation is the square root of 0.56. Next, the second question. Calculate the probability that no woman will be hired by the Cellcom company. So here the probability of a number of hired women is 0. Alright, then substitute into the formula to find the probability of the hypergeometric. K is 4 because only 4 women. And then the X, the selected is 3 employees. And then here is no woman selected. So the X here will become 0. The total number of population and total sample still the same. So just substitute X with 0, K with 4, and the population is 10, sample size is 3. Then you will get the probability that no woman will be hired by the Cellcom company is 1/6. Second example, a box contains 100 blue balls and 50 red balls. 6 balls are selected randomly and without replacement. So here we know that let X be the number of blue balls. This is because the first question stated that what is the probability that all probabilities that are selected are blue balls. So the first case is only involve blue balls. The total sample size is we have the population capital N, we have 100 blues and 50 red balls. Therefore, the population is 100 plus 50. So capital N is 150. And then how many the sample size selected? Only 6 here. In the question stated that 6 balls are selected. So small letter n is 6. And then the key is how many the blue balls in the box is 100. So substitute into the probability that all the selected are blue. So means that we want to select 6. Therefore, the probability that X is 6. By substitute all the values into the formula, you will get 0.0834. Next is, what is the probability that at most 5 blue balls are in the sample? Still blue balls. Therefore, we will use the same population and sample size and also the classification. And at most 5, it means that the probability that selected is probability when X equal to 0, 1, 2, 3, 4, or 5 blue balls. So, to simplify, you can just calculate 1 minus probability that the number of samples select is 6. So we know that probability that 6 blue balls selected is from the previous question 0.0834. So 1 minus 0.0834 is 0.9166. Next, the third question. What is the probability that 4 reds are in the sample? Now, the question refers to the classification of red balls. So, let Y be the number of red balls are selected. The number of balls selected is 6. Therefore, the sample size is 6. And then, the question asks you is, the probability 4 red balls are in the sample. So, we have 6 samples, but only 4 reds, means that the remaining 2 balls is the blue colors. So we have probability that the red ball selected for is equal to the probability of the blue balls, 2 blue balls selected. Alright, then you can just, if you want to use the probability that the 2 blue balls selected is 100 C2 150 minus 100 C6 minus 2 divided by 156. So here you can see that the total sample is the blue color, which is 100. So the probability of the 2 blue balls selected is 0.07974.